Bismillahirrahmanirrahim. Chapter 11, 2 and 3-dimensional models. First lesson, it's about 3-dimensional figures and cross-sections. Our main objectives are to identify 3-dimensional figures, to identify cross-sections of 3D shapes or 3D figures as polygons like 2-dimensional shapes, and use Euler's formula. Okay, so these are our main objectives. First, let's see what is a 2-dimensional shape or figure or object and what is a 3-dimensional figure. So here you can see, as it is written in the definition, a 2-dimensional or 2D object is an object that has only 2 dimensions such as length and width and no thickness or height, and it's very easy to draw the 2-dimensional shapes because they are flat surfaces, or you can say they are flat and they are 2-dimensional. They just have a length and a width, and it's very easy to draw them on the paper. As you can see here, I have drawn a circle, a square, a diamond, and a rhombus. When we think about the 3-dimensional objects, it is an object that has 3 dimensions: a length, a width, and a height. The flat sides of the 3-dimensional objects are 2-dimensional. For example, if we talk about this box that is called a cuboid, it is made up of some flat surfaces. You can say some flat surfaces are joined together to make this box, right? Those flat surfaces are called the faces of the cuboid or the box. Okay, now it's not easy to draw such diagrams on the paper because you have to show that it has some length, it has width, and it has some height. So it's not easy to draw them, but obviously we try to draw them. As you can see here, this is the pyramid. This is shown that it's a sphere, cone, and a cuboid. Now let's discuss some more properties of the 3-dimensional figures. So when we talk about here, if you look at this question, it says find the number of vertices, faces, and edges for the figure. First, we have to understand what is a vertex, what is a face, and what is an edge. All the flat surfaces that are joined together to make a 3-dimensional figure or object are called faces. For example, if you look at this box, we have here 6 faces, 1 in the bottom, 1 on the top, 1 on the left, 1 on the right, and similarly 1 on the back side and 1 on the front side. So it has 6 faces, right? So all the flat shapes that are joined together to make a 3-dimensional figure are called the faces. So this figure has 6 faces, right? I'm talking about the cuboid, this box. It has 6 faces. Now, the line where 2 faces join together, for example, if you look at this line, here, this face, the one that is on the right side, this face and this face are joining together at this line. So this line is called an edge. Okay, so how many lines you can see here now in this box? We can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this one has 12 edges, right? Okay, now what is a vertex? A vertex is a point where 2 or more edges they join together. So you can see here this dotted line and this line and this line, all these 3 lines are meeting at this point. So this point is called singular, is called a vertex, and if you call it a plural, it is called vertices, right? So how many corners or how many vertices does this shape have? Let's count. So it has 4 corners or vertices on the top, and similarly 4 in the bottom. So together it has all 8 vertices, right? Okay, now let's talk about this shape. This shape is called a triangular prism. Remember, what is a prism? A prism is any shape that can be cut into slices, and each slice is of the same size and of the same shape. For example, you can cut this triangular prism into slices and each slice will be a triangle. You can cut this cuboid into slices like the bread, the slices of the bread. So each slice is called a cross section. Okay, Now let's discuss this one. So how many faces does it have? How many edges does it have? And how many faces does it, how many vertices does it have? So let's find out. Let's count. Okay, it has one triangular face here on the top and one triangular face here in the bottom. The rest of the three faces are rectangles. So total it has 5 faces, right? 2 triangular faces and 3 rectangular faces. How many edges? Edges are the lines where the 2 faces are joining. So we have 1, 2, 3, and then we have 1, 2, 3, and then we have 1, 2, 3. So 3 lines for the upper triangle, 3 lines for the lower triangle, and 3 lines for these rectangles. So together we have 9 edges, right? Now how many vertices does it have? It has 3 vertices or 3 corners on the top like this, and 3 corners here in the bottom, right? So together it has 6 vertices. Clear? Okay. So this, here we have some more example. This is a triangular prism. Already I explained it. This is a square pyramid. Remember, a square pyramid, it's not a prism, because if you cut the square pyramid into slices, each slice will not be of the same size and same shape. Clear? But when you cut this, as you can see here, one triangle is here in the front and one triangle is here in the end. So each slice, when you cut it into slices, each slice will be a triangle of the same size and same shape. Hope it's clear for you. So this was some information about the 2-dimensional shapes or 2-dimensional figures and 3-dimensional figures. Now let's see what is Euler's formula. The sum of the number of faces and vertices of a polyhedron is 2 more than the number of its edges. What does it mean? It means that for any shape, when you find the number of faces and you add it into the number of vertices, it will always be equal to the number of edges 2 added into it. As you can see in this diagram, this is a triangular pyramid. You can see here, let's see how many faces does it have. So one of the face is one of the face is a triangle, it's in the bottom, and 3 triangles are standing. So it has 4 faces, right? I'll just write F for the faces. So it has 4 faces. How many edges? So we have 3 lines in the bottom and 3 lines are going upward to this corner. So how many edges does it have? It has 6 edges. Okay, then how many vertices does it have? So we have 3 vertices in the bottom and 1 vertex on the top, so it's 4. So according to this formula, if I put these values into this formula, you will see that the left hand side and the right hand side are equal. So how many faces? It has 4 faces. And how many vertices does it have? It has 4 vertices, and on the other side I have 6 edges with 2 more. So you can see here, this side is giving me 8 and this side is giving me 8. So whenever I want to check that the given information, can it make a polyhedron, I can put the values of the faces and edges and the vertices into this formula to check. Clear? But usually how do they give us the question? They give us the question like this. Like for example, if you look at this question, it says a polyhedron has 12 faces, 30 edges. How many vertices does it have? Right? Okay, so we will write the formula. It says F plus V equals E plus 2. Now let's put the values into it. How many faces? So F will be replaced by 12, and vertices we don't know, so leave it. And how many edges? There are 30 edges, and we have 2 more into it. So this one will become 32, right? 30 plus 2 will become 32. Now move this 12 to the other side. So it will become V equals 32 minus 12. So the number of vertices will be 20. Clear? So this is how you can find the missing number of either the faces or for the edges or for the vertices using Euler's formula. The next B part, it says, can a polyhedron have 4 faces, 5 vertices and 8 edges? This is also important, that sometimes we have to only check that will with these faces, vertices and edges, can we make a polyhedron? So let's check. So this is the formula: F plus V equals E plus 2, and then you will put the values into this formula. There are 4 faces, so F will be replaced by 4. 5 vertices, so V will be replaced by 5, and number of edges are 8, and then 2 will be added into it. Now when we check, the left hand side is giving us 9. So the answer for the left hand side is 9, while the answer for the right hand side is 10. So the left hand side is not becoming equal to the right hand side. So you can say no, these faces, vertices and edges cannot make a polyhedron. Clear? This is how we can check. Now let's discuss what is a cross section. So as you can see here that we have been given an octahedron, and they have 2 planes are passing through it. One is of blue color and the other one is of the orange color. Plane M and plane N intersects the regular octahedron as shown. What is the shape of each cross section? So cross section, as I told you, that when you cut something into slices, sometimes the slices are of the same shape, sometimes the slices are of different shapes. So as you can see here, the blue one, the plane M, slices the octahedron in half through the top and bottom vertices. The cross section is a rhombus. So when you cut it like vertically with the blue card, or you can say with blue plane, you will get a rhombus. Like each part of the octahedron will give you a rhombus, will show you its face will become a rhombus. Okay, plane N slices horizontally between the bases of the 2 square pyramids. The cross section is a square. So if you cut it this way, where my cursor is moving with the plane N, you will get square. Okay, now if you look at this diagram, it is saying what shape is the cross section shown. For example, if you name this plane M, that plane M is, you can say, cutting this pyramid into 2 parts. One part is here in the bottom, one part is on the top. What is the shape that you can see here? So clearly you can see it's a pentagon, right? You can see that this will give you a pentagon on the lower part of the pyramid, and a pentagon here on this part of the pyramid. What shape is the cross section if the plane is perpendicular to the base and passes through the vertex of the pyramid? It means that if you cut it downward like this, what will be the shape? So it will become a triangle. If you cut it downward, you will see that both the slices will have on them the triangle. Clear? Okay, what if we rotate a polygon to form a 3-dimensional figure? Here in this tried question and in this example, you can see that they are rotating a triangle. So if you rotate a triangle very fast, it will show you a 3-dimensional figure, that is a cone. Similarly, if you rotate this triangle, you will get a shape of a cone. What if you rotate a small rectangle very fast? So it will give you the shape of a cylinder. Now here we have some questions from the lesson. Let's see what do they want us to solve. A polygon has 24 edges, 12 vertices. How many faces does it have? So you will make use of the Euler's theorem and you will find the number of faces. So what is the formula? I'll write over here for you the formula. So it is F plus V equals E plus 2. Now we are given the number of edges 24, so it means you will replace this E by 24, so 24 plus 2 will become 26. And on the other side we are trying to find the number of faces, so F will be F plus vertices are 12 equals 24 plus 2, so it will become F plus 12 equals 24 plus 2 will be 26. And now you will move this 12 to the other side, so you will have here, I'll write it over here. So you will have number of faces equals 26 minus 12, so it will give you 6 minus 2 will be 4 and it's 14. So it will have 14 number of faces. Now better pause the video here and solve question number 17, 18, 19 on your own. So here are all the answers. I made use of the Euler's theorem. I substituted the values, and then it was very simple to find the missing, you can say, vertices, faces or edges. Here is the next question. They said draw the cross section formed by the intersection of a plane A and the polyhedron shown. What type of polygon is the cross section? So if you cut this polyhedron with the help of this card or with the help of this plane A, what will be the shape? As you can see here, it will be a hexagon. Why? Because you can see here one of the vertexes here, one of the vertexes here, and one of the vertexes here. So it's giving us a shape like a polygon. Let me show, a shape like a hexagon. Let me show you. So here you can see clearly this is the shape, this one, 2, and it is like this. So this shape is a hexagon. Clear? Let's see what do we have next to solve. Here it says which best describes the cross section of plane X and the polyhedron as shown in this diagram. So clearly you can see the piece that is cut from here is giving us a pentagon. So what will be the answer? The answer will be a pentagon. Let's see what do we have next. It says complete the table. For each polyhedron you will make use of the Euler's theorem to find the missing. For example, here they want you to find the number of vertices. Here they want you to find the edges, vertices and faces. So better pause the video here and complete the table and then play the video to check your answers. So here are all the answers. I made use of the Euler's theorem to find all the missing values. It was very simple. Let's see what do we have next. It says these are the challenge questions. Read them carefully, try to solve them on your own, and then I will show you the answers. Better solve these on your own first. Here are all the answers. The first one, I made use of the Euler's theorem. You can see here it's explained here. So we are getting the number of vertices 20, and then which shape when you cut it with the help of this gray plane, so you will get a pentagon. It's like this. Okay, we cannot see the other side of this polyhedron, but it will be a pentagon. And then according to Euler's formula, what does it state? It says sum of the number of the faces and the vertices. So first we add the number of faces with the vertices of any polyhedron. It is always equal to 2 more than the number of edges. Like on the other side, we always have 2 more than the number of edges. That's all for this lesson. Hope you understand it.